5-2, dividing polynomials. So we're going to talk about how to divide polynomials in this case. So first, let's talk about how you divide by a monomial. When you divide by a monomial, when you divide by a single term down there, all the best thing to do is just split it up. Just split it. So you can get 4x over y squared over xy minus 2xy over xy plus 2x squared y over xy. Then you just simplify each one separately. So like here the x's cancel. Right here you have one more y on top. So you get 4y. Here the x and the y cancel. You get negative 2. Here the y's cancel and 1x cancels. Plus 2x. And that's it. That's how you divide by monomial. You just split it up and reduce. Now where it gets a lot more interesting is we can divide by a binomial or a trinomial. Anything higher than the monomial. And actually let's change this real quick to make it something that works. Let's make this 16. So the first way to doing this is to factor. So let's rewrite it first actually. It says x squared minus 6x minus 16 over x plus 2. And one way to do this is just factor. So I can factor the top. That's x minus 8x plus 2 over x plus 2. Then the x plus 2's cancel and you just get x minus 8. So that's one way to do it. And you might say to yourself, wait, what happens if you can't factor? Like this one. In this case, I actually could factor top a little bit. I could factor out a 2, but after that, it is prime. Nothing else factors from that. So what do we do in this case? Well, first we can do, one thing we can do is long division. Just like when we learned in grade school. Still works. So we're going to do long division. So most cases, like always, if you can factor, great, it's the easiest way of doing it. If not, if you divide by a binomial and you can't factor, then we're going to go to long division. So before we go to long division, let's actually review long division. Let's make up a number real quick. So remember, if you remember how you do long division, we look at the first two. Go, how many times is 3 going to 2? In this case, it can't. So we actually look at the first few. 3 goes in 25, 8 times. And then we multiply. Alright, so I get 24. And then we subtract. I get 1. And then we bring down. And then we repeat the process. 3 goes into 11 3 times. Multiply, you get 9. Subtract, you get 2. Bring down the 4. I get 8. So this is 24. So let's bring down the 5. 3 goes into 5 one time. Subtract, you get remainder 2. So my answer is 8, 3, 8, 1, remainder 2. That's one way to write this. By the way, another way to write the remainder, like a more mathematical way, less of a baby way, is 8, 3, 8, and then you get your remainder over what you divided by, and 2/3. So those are equivalent. So either way is fine. 8,381 remainder 2, or 8,381 2/3 and 2/3. So that's long division. And we're going to do the exact same process for the two problems we just did. So like this first one, let me change it back to 16. Right, so let me change it back to 16. Let's do long division. So I'm going to rewrite this. X squared minus 6x minus 16 and x plus 2. Now again, we did this problem already. I know what the answer is. The answer should be x minus 8. It's the exact same problem. Now let's do long division. So what we do is long division. Now we're going to look at the first one and the first one here. I could care less about the 2 for now. Just look at the first two. We'll have to multiply x by to make it x squared. And it'll be x. Right? I only have one x, I need 2 x's, so I'm missing an x. And then we do what we do in long division. We multiply, we subtract, we bring down, and repeat. So we're going to multiply this x by both of these. X times x is x squared. X times 2 is 2x. Right? So I figured look at the first two and go, what did I multiply x by to get x? In this case, it's just x. Multiply by everything in here. So you get that. Next up is we subtract. So here's the key thing about subtracting. This is where most people make a mistake. I like to put parentheses. You're subtracting both of these. So that makes this a negative x squared and a negative 2x. So then when we add, these cancel out, and I get negative 8x. Bring that down, minus 16. Right, so just like normal long division, we multiply, we subtract, then we bring down. And then we just repeat the process. Look at these two. Look at the first one again. All we care about is the first one. What did I multiply x by to get negative 8? In this case, you say negative 8. Negative 8 multiplied by both of these, and I get negative 8 times x is negative 8x. Negative 8 times 2 is negative 16. Again, we are subtracting. So it's minus, distribute, you get positive 8x and positive 16. They cancel out. I get no remainder. Answer is just x minus 8, which is the exact same thing I got over here, right? The exact same thing. So that's how you do long division. Just like essentially the same way you did it back in 4th grade. Just, what do the first two, what do you multiply this by to get that? Subtract, multiply, subtract, repeat, bring down, repeat. I had said that terribly. Multiply, subtract, bring down, repeat. So let's do it again. And I'm going to stop talking. So we're going to do this one. Remember, last time we couldn't do this one. It didn't factor, so we couldn't divide it. So now we're going to do long division. And what's going to happen is, since we couldn't divide last time, we're probably going to get a remainder this time. Let's do the work, right? So all we care about is the first two. We multiply a by to get 2a squared. That would be 2a, right? I need an a and I need a 2 and an a. Now we're going to multiply this 2a by both of them. So 2a times a is 2a squared. And 2a times 1 is positive 2a. Then we're going to subtract. Again, I like to distribute so I don't mess myself up. These cancel. Negative 4a minus 2a is a negative 6a. We'll bring this down. Then we repeat the process. Look at the first one, and look at this one. What do you multiply a by to get negative 6a? Well, that'd be negative 6. That's the only thing we're missing. Multiply that negative 6 by both of them. Then we distribute. That becomes a positive 6a, and that becomes a positive 6. These cancel. Negative 8 plus 6 is negative 2. So that's my remainder. So my answer here is going to be 2a minus 6, remainder negative 2. Or 2a minus 6. Remember, we can put this over what we're dividing by. So you could say plus negative 2 over a plus 1. So again, both ways are correct. This one's a little more classy. Both ways are fine though. So now we can hopefully kind of get the feel of it. Let's move on to harder examples. Look at this next one. We're going to divide all this by 3x plus 1. Looks like a handful, but it's honestly the exact same idea. We got 6x to the 5th plus 5x to the 4th plus x cubed minus 3x squared plus x. Now if you notice we're missing a constant term, I like to add it in to make sure we're not. Anytime something's missing, you want to add it in. So if there's like if they would have skipped x squared, I would put 0x squared. So you just want to add in what they're missing. We're going to divide by 3x plus 1. Right, and then it's the exact same process. We're going to go, okay, how many times does 3x go into 6x squared to the 5th? Well, I need to multiply by 2, and I'm missing 4x's. Multiply this by both of them. 2x times 3 is 6x to the 5th. 2x times 1 is 2x to the 4th. Subtract. Gone. 5 minus 2 is 3x to the 4th. Bring down the next term. And we're going to repeat the process. So we're looking at the 3x and the 3x to the 4th. All I need is x cubed. Multiply by both. Subtract. And this one, they all cancel out. So what do I do here? I'm going to bring down the next, like you can bring the next one, negative 3x squared. And I'm actually bringing the next two. So I could fill out my thing here. And then we do the exact same thing. What do you multiply 3x by to get negative 3x squared? That would be negative x. So negative x times that is negative 3x squared. Negative x times 1 is negative x. Subtract. These cancel. I get a positive x, so 2x plus 0. So we have that, and then you're like, wait, would I multiply 3x by to get 2x? And that kind of sucks. It's a little math trick. If you want to get rid of the 2x, we got to multiply by, I got to make a 3 a 2, so that's how pro we are. You want to cancel the 3, so put 3 on the bottom, and you want a 2, put a 2 on top. Hope that makes sense? Right. I'm trying to get a 2x right here, so multiply by 2/3. That way, 3's cancel, and I get a 2. It's a little advanced math trick there. So let's multiply that by both. And I get 2x plus 2/3. Subtract, gone, and I get negative 2/3 is my remainder. So that's the answer to that one. Alright, it's a little messy, but hopefully you see with the first part, it's the same thing. Just bring it down, subtract, repeat, bring it down, subtract, repeat. Just like we always do in normal long division. Now, if you don't like that method, there's another method there's a little shortcut method called synthetic division. So we're going to have to get used to this lesson because we're going to do it a lot over the next couple of lessons. We're going to do a lot of dividing. And this is the fastest way to divide and to find roots, which we'll talk about later. So there's a catch, though. So synthetic division is a nice, fast method. There's a catch, though. It only works when dividing by a linear basic linear binomial. So with that I mean you're dividing by like x plus b or x minus b. For example, x plus 3 or x minus 2. So it has to be something like that. Now if there's a number form we can work with, and we'll talk about how to work with it, but it has to be a linear binomial term. It can't be x squared plus 3, it can't be a trinomial, it can't be anything else. It has to be super basic. Then we can do synthetic division. Now, synthetic division itself is a little funky. It's got to get used to it. There's a pattern to it, and we'll talk about it. But that's the first key. That's the first key of synthetic division. You can only use it when it's a basic one. Okay, so let's talk about how to do it. First, let's set it up. So what I'm gonna do is rewrite this. So x squared minus 6x. I rewrote that to be negative 16 to match what we did earlier. And then with this, we're gonna kind of write like this. We're going to write down the coefficients. So 1, negative 6, and negative 16. I like to write an arrow underneath the first one because we bring that first one down. I like to write a box at the end because that's our remainder. Now what we're going to do is put a box on this side. What goes here is opposite of what you're dividing by. So this is x plus 2. It's kind of like inside opposite. We're going to use negative 2. So if I had this, we'd use positive b or 2. If we had this, we use negative 3. So use the opposite, so the inside opposite. And what goes on is this. We're gonna, here's the steps. Bring down first term. That's why I have the arrow. So we're gonna bring that 1 down. And then 2, I forgot to put the negative 2 right here. We're going to multiply across. So multiply that 1 by that negative 2. So 1 times negative 2 is negative 2. And then we're going to add down. And then we're going to repeat. So I'm going to add negative 6 and negative 2. We're going to add down negative 8. Then we're going to repeat the process. Multiply across. 16, we're going to add down, we get 0. So we get this. You're like, okay, what's that? Well, we just divided. Now here's the last key part. The thing you divided by, so right, we're dividing this by x plus 2. So you always lose 1 power. So this becomes, that was x squared, this becomes x. And then this goes in order. X minus 8. Remainder 0. Right, so we get x minus 8, which is the exact same thing when we did it long division up here. X minus 8. It's the exact same thing when we did it factoring. So no matter which way you do, you get the same answer. Now the good thing about factoring is it's fast, but it doesn't always work if it's prime. So long division is the only one that works no matter what. Long division is always going to work. It's a little long though. Synthetic is like a happy medium where, oh, we're dividing by a basic linear term. We can do synthetic division. It will work for that case. But that's the general idea. So let's do one more example to make sure we got this. So this one right here. Again, first thing we do is rewrite it. So, I'll rewrite it. 3z minus 6z cubed minus 9z squared plus 3z minus 6. So coefficients 3, negative 6, negative 9, 3, and negative 6. Bring down the first term, so put a little arrow here. And the last one's always my remainder. So in this case, again, we always do the opposite of this. We're going to divide by negative 3, inside opposite. So, steps, right? Bring down the first one. So we're going to bring down that 3. That's why the arrow's there. Then we're going to multiply across. So 3 times negative 3 is negative 9. We're going to add down negative 15. Multiply across 45. This is getting ugly. Add down 36. Multiply across negative 108. 90 plus 18. Yeah, negative 108. Haha. Add down negative 105. Oh, gee. Multiply across 315. Positive 315. And then add down 309. Hope that's right. Otherwise, I'm embarrassed myself more than once today. So we have that. So again, just bring it down. Bring the first one down. Multiply across. Add down. A lot of people try to subtract. Just add. Easy operation. Add. Multiply across. Add. Multiply across. Add. Now, remember the rule is it's always 1 power less. So this is x to the 4th. This must be, or z to the 4th, something 3z cubed. Then you just go down in order. That's z cubed, that must be 15z squared. That must be 36z. That must be the constant term. And we have a remainder of 309. Or if you're pro, you can write it as 3z cubed minus 15z squared plus 36z minus 105 plus 309 over what you divided by, z plus 3. Oh, look how cool that looks. So that's the idea of syntactic division, right? That's us doing it again. It's all about bringing down the first term. If you're dividing by basically you do the inside opposite, negative 3, multiply across, add down, multiply across, add down. This is another one. Now there's a reason I'm doing this one. If you notice this one, it's y5 minus y3. If you remember what I'm talking about, stuff is missing. I don't like having stuff missing. Anytime it's missing, I don't care which way you do it, you want to add in zeros. So this is missing a y to the 4th, a y cubed, and a basic y. So you want to add those in, so that everything kind of falls in order still. So we're going to have y, let me rewrite it first. Y to the 5th. I don't have a y to the 4th, so plus 0 y to the 4th. I don't have a y cubed, so 0 y cubed. Minus 3y squared plus 0y minus 20. Inside opposite, we're going to divide by 2. Don't forget to bring the first one down. I should write the coefficients. And the last one's the remainder. So we get something like that. Alright, again, cannot stress enough. I don't care if you do long division, same idea. If you're missing stuff, add it in. It lets you keep all your stuff straight. And then if we're doing synthetic, all we do is bring the first term down, multiply across, so 2. Add down, multiply across, so 4. Add down, multiply across, so positive 8. Add down 5, multiply across is 10. Add down 10, multiply across is 20. Hey, we get no remainder. Woo! So remember the way we write our answer, it's always one lower. So this will be y to the 4th. Then you just go in order. Plus 2y cubed, plus 4y squared, plus 5y, plus 10. And that's the answer. So those all have been the basic syntactic division. Now let's go to what I talked about earlier. What if there's a number in front? What if it's ax plus b? You can still do it. We got to play with it a little bit. So let's go to a couple of those. So this first one here. So we're going to divide this by 5x plus 10 plus 5. So in this case, remember it has to be ax plus b, or has to be x plus b or x minus b, so we can do syntactic division. So one way to do this is you just divide everything by the the number in front. So divide it all by 5. So in this case, I'm going to get 2x squared plus 3x plus 4 divided by x plus 1. And I could just do normal syntactic division. 2, 3, 4. We're going to divide by, it's opposite, -1. Bring the first one down. That's our remainder. Multiply across, add down, multiply across, add down, and get that. So my answer in this case would be 2x, right? It's always 1 power less, plus 1, plus 3 over what we divided by. In this case, we divided by x plus 1. So that'll be my answer. But before we move on, a little warning. If you check your answer in the back of the book, it probably won't have that. Because back of the book, a lot of times they want you to go back to the original, we divided by 5x plus 5. Now this is equivalent to the exact same thing. This is a perfectly fine answer, you get full credit. But if you want to go back to the original, so they want you to go back, a lot of times they'll have this in the back. They're divided by 5x plus 5. Well, what they did was, you know how we divided by 5? They went back to the original, so it's being multiplied by 5. Which means you also got to multiply your remainder by 5. Because you got to make an equivalent fraction. So it'll be a 15. So in the book, you probably see this as the answer. Again, it's the exact same thing. This is why we write in this. That's why we prefer writing this term instead of just remainder, because you know what the context is. Oh, remainder 3 when you're dividing by x plus 1, instead of saying remainder 3, this one would be, you would have remainder 15 when you're dividing by 5x plus 5. So again, this is totally fine, and this is totally fine too. This is what you're going to see in the book. So the next one, it's going to be a little uglier. So you see the 3 there. I'm going to divide everything by 3. I get 6a squared plus 2a plus 3 divided by a minus 2. So we can do some division. A minus 2/3, sorry. I almost said that. I was like, that's too easy. So you have 6a squared plus 2a plus 3. Again, inside opposite, we're going to divide by 2/3. Bring the first one down. This remainder. So we bring the 6 down. I'm going to bring down the coefficients. You multiply, right? You multiply fractions. 12 times 6 is 12. 2 times 6 is 12. Divided by 3 is 4. Add down. Again, we're doing the coefficients. I didn't write it because I'm lazy, but you're supposed to do coefficients. So you get 6. 6 times 2/3 is going to be 4 again. 3 plus 4 is 7. And again, 1 power less, so 6a plus 6 plus 7 over what we divided by, and we divided by this. A minus 2/3. Right, so again, totally fine answer. Right, it's an equivalent fraction. We just reduced it, so that's all good. If you want the book answer, the book likes to put it over what you divided by. So we divided by 3a minus 2. So what they did is they multiply this by 3, and they multiply that by 3, so they get 21. Right, so again, if you want the book answer, it looks like this, but both of these are totally fine. I think I got one more of these, one that's really ugly. And no, I don't. What I do have is other type of problems. So now, not all problems are done by syntactic division. If you look at this, like how am I going to syntactic divide or long? You can still long divide if you want, but there's an easier way to do this problem. So this is let's call this random divides. Random problems in dividing. So the best way to do this one is actually by factoring. So always your best way is by factoring. I could factor this top. It's the difference of 2 squares. That's going to be x squared minus y squared, x squared plus y squared, all over x minus y. And like what? They still don't cancel out, right? Well, I could factor this again because it's still a minus. I can't do the plus. Plus is stuck. But that breaks down to x minus y, x plus y, times x squared plus y squared, all over x minus y. And then here the x minus y's cancel out, and I'm going to select my answer. X plus y, x squared plus y squared. So again, look at the problem you're doing. In this case, I was like, oh, it's much easier to factor. Like syntactic would be incredible. Long division would just be a lot of work. And you can do this one right here. It's kind of your choice. You could factor. You can do syntactic division. Whatever you want to do. I think actually for me the easiest way is probably syntactic division. If I was going to do this, is the last problem we're doing. I think syntactic division is kind of the easiest way. So say 1, 2, -7, -21. Bring the first one down. We're dividing by -3. So bring the first one down, multiply across, add, multiply across, add, multiply across, add, and I get 10. Hey, look at it. We wouldn't divide it evenly anyway. It's always 1 power less. So p squared minus p minus 4 plus 10 over p plus 3. There you go. That's the deck in long division.